Okay. Not quite ready to get started, but I am going live anyway. Make sure the chat's working. I'm also gonna go get a donut downstairs. Probably find my glasses. So, be right back. Alright, part of the way there, I still need to get that donut and get some water. Let me put some, let's see here, anything you guys want to see on the screen besides my room? I'm gonna YouTube this, so. Alright, what else? Yeah, I'll be right back and then we'll get started. Alright, this time I'm back for real. We'll get started in just a minute. Feel free to say hi in chat. We're kind of a low latency mode. This is streaming on, interacting with people on Twitch is actually less frustrating now. We're listening to more Disaster Piece. I think, right? Let me know if you want me to turn it up. Okay. All right, now we're ready to go. Let's see. So let me explain what we're trying to do here. That was weird. So, if you're familiar with Go, and feel free to ask any questions about Go during this, but Go is pretty big on interfaces, and one of the kind of canonical interface examples here is in IO, which is a couple of interfaces that are sometimes used together, and then a bunch of kind of utilities around using those. So for example, you have a reader interface, which is just something that has a read method, and similarly there's a writer interface, and there's a couple of variations, but then you can see there's built in a couple of both kind of like adapters, so you can create multi-writers and stuff like this. The popular, very commonly used thing here is copy, which basically says, hey, given a reader, copy that into a writer. And so these kinds of interfaces and abstractions are really a big part of programming in general, but I feel like they put a little bit more attention to them in Go, and designing kind of these simple composable interfaces and then designing tooling around them. And one of the things that I write a lot are SSH servers SSH servers, as well as things that shell out to the command line, as well as stuff with Docker. And all of those kind of have the same kind of data structures involved, dealing with, it's not just a straight IO reader. You have several IO things. You have standard air, standard out, you have standard in to worry about. You have the structure of most things usually has environment, a working path, the thing that you're going to run, and when the process finishes, you have an exit status or an exit code, and that's pretty much common whether you're using a Docker API to run a container in Docker, or to run a command to shell out with exec, or if you were to use an SSH client to do either of those things. And the thing that I write a lot are SSH servers, which will often either exec something or run Docker, or something else entirely, which is one of the cool things of having a SSH library, as good as the one that we put together here at Glider Labs SSH, which is actually just wrapping the crypto SSH package and giving you an API that's a lot more similar to the HTTP, net HTTP interface, But SSH is kind of, you know, when you really get into HTTP and HTTP2, there's definitely a lot of complexity, but kind of the basic HTTP stuff is a lot simpler compared to the basic SSH stuff. So it's still a little bit harder because SSH is actually a stack of a layered protocol stack that lets you do different things at different layers. Like you can kind of use it just beyond authentication. You can use before it even gets to what people think of as SSH with sessions, you have this kind of multiplexing channel layer that you can use for basically arbitrary channels, streams of data, multiplexing over this encrypted connection. And then you have sessions as well as variations of kind of typical SSH things or whatever else you want to do. And so this library is really good for the common cases, and we're kind of pushing it to handle you know, other kinds of channel handlers and stuff like that. But it's, you know, it's under Glider Labs, but Glider Labs is not necessarily like, it's basically, Glider Labs doesn't really make any money anymore, so plus everything that we did as open source was sort of like in free time anyway, so what we're gonna kind of start with here is actually in the examples, because one of the examples that I have here is which it looks like my friend Steven wrote up a little readme for this, which is kind of cool. But this is an example of an SSH server where when you connect to it, it will run a Docker container, and then that session, it'll basically attach you to that session. And so this is kind of our kind of what I want to use to figure this out. And then what we figure out here should also work for Exec. So in theory, we could create an SSH server that generically will run a, we'll call it like a runnable or something like that, or yeah, runnable. And that could either be like an exec command, or a Docker run, or another SSH client connection, and then our abstraction would allow us to create a generic SSH server that would kind of work for all of those. Maybe, we'll see. So this is sort of an exploration, what we can get out of this kind of abstraction. You know, I do this a lot, and so I end up doing a lot of the same things in terms of you know, copying both streams, dealing with whether it's a in a terminal mode, handling the status code, and other stuff associated with SSH. This will be interesting because I'm not sure that I want to get too SSH specific in this abstraction, so making sure that this is, I don't know, extensible or something, we'll kind of figure this out. Any questions? A lot of people kind of hanging out but not saying anything. Feel free to say hi or ask any questions at any point about anything, about Go, about me, about other projects. I probably won't spend too much time on talking about other stuff, but let's see. I think that's enough to start. I'm not even sure I have this checked out, so let's grab this. That's funny. Does anybody know the quickest way to open something in code from the command line? I don't think there's a command line. Maybe VS Code. No, I don't know if there's any kind of command line thing installed. Just resort to doing something like this. So let's look at this example. All right. Hey, Zacho. The epic music. I don't know. This is the different theme of project. I figured I would kind of listen to. Normally, when I work on games, I'm listening to Super Nintendo music, which there is a lot of. That's interesting. And so instead, we're listening to Disaster Piece, which is a little bit more atmospheric. If you want me to turn it up, let me know. It might be a little quiet. Some good stuff. Turn it up. Yeah. Drown out my voice. We're not really here for me anyway. If other people say turn it down, I will turn it down. Just let me know. Because I don't actually hear. I can see, you know, a little bit in what the levels are, but I don't know how that it actually sounds. How's that? You know, when I was working on Flynn, we actually tried doing a Docker run interface that implemented the command exec API, which I think turned out okay. I think it ended up being slightly different, but I'm not sure if they still use that abstraction. So why don't we look at what we do here? Actually, we can run this and see how this works. Let's see. I'm not sure if we need to run this. Is this hard coded to some command? No. Oh, I see. This is an example Docker file with JQ. All right. We'll call it JQ, I guess. So I'm just creating a container that has JQ in it, which is a JSON parsing query tool. And just to use it as an example here, I guess we can try it out. Docker run. It's been a while. I think I have a shortcut for this. Docker run JQ, and let's see. I don't have any JSON to try. Let's do something like I don't actually know if this is the what is it doing? I think we came up with that. I use that all the time. Okay, so it's working. I don't know why it was slow before. So then if we were to do DRI, which is basically Docker run with a bunch of RM and IT, Docker run interactive basically. This should work, which should colorize it. Doesn't seem like it worked. JQH, get the help, and here it should do nothing. Oh, you know what it might be? Which it seems kind of pointless because it's not colorizing it now. That's funny. I think if we wanted to do this, we'd have to write it to a file first or something like. And then maybe cat it. Or maybe it'll complain there too. Maybe this is a new Docker thing, because this is, it's been a while since I've used Docker, and I've never seen this before. But obviously we can get it to work like this. There's a location. So it works. It's just not colorizing it because it's saying it's not a terminal, because when you pipe stuff, anything in that pipe chain is not run in the context of a terminal, even though you're in a terminal. Okay, so we got that there. It's maybe going to be a little bit more frustrating to test if we can't test the TTY stuff. But let's try and run this now and see how good these instructions are. Let me know if the text is too small. This is a pretty fresh Go workspace, so you have to grab a lot of things. I think the Docker client's a big thing because it's basically grabbing all of Docker. So I'm new to using this terminal in here. I'm guessing I can't open new tabs. I mean, I could try. Well, I'll just use the terminal here. Well, that's weird. Where should I put it? So I should be able to SSH to localhost 2222. JQ localhost. Okay, so it runs it. If we were to cat, so this is probably going to give us our oh, we're not in the right directory. JQ app closed. Pseudo terminal will not be allocated because standard in is not a terminal. Maybe it's a new bash thing, because I don't remember ever running into this. Like this. Okay, so yeah. So what it's doing, it's piping that program JSON over SSH, connecting to localhost 2222, which is our little bridge that we're running. The username JQ is being used to determine what Docker image to use. And then the arguments are passed as the arguments to the Docker container on Docker run. So already this is kind of a nice little bridge, you know? You could imagine writing a Docker as a service or something like that, where you don't even need Docker on the client side to use Docker. But the point is that it kind of feels like a mess. And so the idea is, how can we clean this up? And how can we try and get an abstraction out of it that we could use for other stuff, like doing an exec or something like that? So maybe we will. This is kind of unrelated to the SSH project, but I'll be working on it in here anyway, specifically on this SSH Docker example. And then we can pull it out and do other stuff later on. So let's kind of see what's going on here. The Glider Labs SSH library makes it pretty straightforward to do basic SSH server. You can just do SSH handle with a callback that takes a session, just like you have kind of that high-level simple HTTP handle in NetHTTP, and then you do SSH listen and serve, and it'll use that default handler and serve. So what we're doing in this handler is the session is a pretty big interface. One of the things is it lets us get whether or not the SSH client is expecting a terminal, and so we actually get a couple of things here, but we only care about the Boolean of whether or not it's been requested. We set up the Docker container, which is pretty standard, kind of an empty volumes thing. Standard in once, do attach all IO, open standard in because we probably expect things to be piped in. Set the TTY to what was requested. So this is going to be used for the Docker run. Get the environment. We actually get that from the session. So if you SSH, you can actually write session variables as well as inherit your current session. I think there's a way to do that. which is not commonly used. But in case you do it, we capture that environment and pass that into the container. The command that we run in the container is basically the command that was passed over SSH. We get that from session command. And the image that we use, like you notice, is coming from the user. So once we have that configuration, I have some basic abstraction here called Docker run, which takes the config and the SSH session, and it returns whether or not there was an error. It returns kind of a cleanup function, and the status of, once it's run, what was the exit code. So then we do a defer, which, if you're not familiar with defer, basically means run whatever this is at the end of this scope definition. This is basically saying the last thing you do is clean up. Then we check the error. I'm not sure if it makes sense to do cleanup before, to defer cleanup before. Usually do that after. I don't know what I was thinking. We both print out, we do an fprint to write to the session whatever the error was. If there was an error, for example, if we were to run this, and then I think request, try and run a container that doesn't exist, right? We would, let's see, how can I guess I'll just reset it every time. Probably better to persist it. So I have to do this again. So then there's what was printed out during the error, no such image. So that's this bit of code. And it's also in the logs here. And then we do an exit. So whatever that exit, if we were to, let's see, Docker run, I'm pretty sure if there was an error in here, we return 255, and so we exit with 255. You can see that there. And it's by calling session exit. So that's pretty straightforward. It's just kind of a made-up abstraction here. So let's look at what we do in here. And we're not going to be able to clean all this up because a lot of it is specific to Docker, setting up the container, etc. It'd be nice to clean that up, but I'm mostly interested in extracting an abstraction for any kind of runnable. So we'll try and generalize it with an exec command once we have something. So Docker run, we set up a new client based on whatever's in the environment. Our default status, since we have named return values, we kind of set their defaults by just assigning them up front. So by default, the status will always be 255 if something goes wrong and we return early. Cleanup is an empty function. We set up a context because all these Docker API calls require context. We don't actually use that. We're just kind of doing it because it's required. But you can imagine having a timeout or something like that. First, so when you do a Docker run, it actually does a couple of things at once, depending on what your arguments are. But generally, it's first going to create the container, which doesn't run the container. That basically sets up a file system to be able to run that environment. And then you can start the container, which also doesn't really give you anything other than, hey, we started. And so then it requires you to attach to the container to actually get anything from it. And then after it's run, if you run with the --rm, it's going to clean it up afterwards, which is basically the equivalent of container remove. So our Docker run, when you do Docker run, it does all those things. So our Docker run is also doing all of those things. And so finding a good way to do all of these. But anyway, first we do a create, and immediately then we set cleanup to be a function that will do Docker remove. So no matter what happens or where we return, our cleanup function is going to do a remove to clean the container up, which is kind of obnoxious when you're debugging stuff, because if you want to look at the container, but this is just, if we needed to debug it, we could comment that out. When we do the attach, we actually attach first before you start it, just in case you know, you miss any data. It takes a little bit longer for it to attach than it does for it to actually start. So you attach first and then you start. Attach has some options. Lega Metrachin, thanks for following. Be sure to turn on notifications if you want to get emailed when I'm streaming. It's kind of helpful for a lot of people. But thanks for that. Feel free to say hi in chat as well. Container options is kind of weird because it's usually you're saying, hey, what do you want to attach? And it's usually all or nothing. I mean, I guess there's some cases where you don't care about standard in. Usually if you want standard out, you might as well get standard error. So this is just kind of some obnoxious boilerplate. The other is stream true, which I forget what happens if you don't do true. Maybe it acts a little bit more like logs, where it kind of just gives you what it has. I don't know. And then quits and you lose the persist. I don't know. But anyway, we want to stream, so stream is true. We do the attach with the doc container ID from our result from create, pass those options, and we get a stream object, which is kind of close to the kind of abstraction that I'm thinking about, but it's not. See, I'm wondering why VS Code is not doing any kind of autocomplete here, because it should know what that is, right? Docker container attach. It returns actually a hijacked response. I did not expect that. So stream is a hijacked response, which we're not getting any kind of autocomplete for some reason. I wonder if it's because okay, so that's interesting. Weird things about VS Code I'm getting used to, like certain things are not updated until you save, which I guess makes sense. So now we can get a reader, we can get the underlying connection, we can close the write channel, we can close the whole channel. So once we have that, we update our cleanup function, basically override it to both remove as well as close that stream. Probably should be the other way around, close the stream and then remove, but here, okay, we're gonna create an error channel. Let's see, so this is where TTY comes in. Because actually, when you run in a terminal mode, TTY or PTY mode, standard error is rolled into standard out. One of those kind of weird things of understanding how the console and terminal stuff works, but so if it is a TTY, all we care about is copying the stream's reader into the session, which is a writer. If you write to the session object that we're passed, that writes to the end user what they see on their console. And so we just do IO copy. Otherwise, and this is weird, we have this standard copy package which Docker comes with, which basically says, because they basically encode both standard error and standard out into a single stream, and I don't know what they're doing now, but at one time they were basically I forget where I think this is a standard, they would actually prefix it with some terminal escape codes that let you specify a header, which you could use, for example, to say whether this line is standard out or standard error. but it could be just JSON. I don't know what they do under the hood. But anyway, standard copy basically demultiplexes reader and then spits it out into whatever standard out you give and whatever standard error you give. Which, the way session works, it is a writer for standard out. If you want a writer for standard error, you call standard error on it. It gives you a writer for standard error. Which is actually how the underlying SSH library generally works as well. If there's an error with either of those, we we send it on the channel output error. So we can get that error from these instances running asynchronously. And it looks like we also run, basically for standard in, anything that was passed via SSH through standard in, you can read off the session object that we have. So we have that as the reader, and then we write that directly to the connection of the stream, which is interesting, but makes sense. They don't need to create any kind of reader buffer because they're not splitting out standard error and standard out. So you write directly to the connection, and then at the end of that, apparently we don't care what the error is. At the end of that, make sure you close the write on the stream, just to kind of clean that up. I'm not sure how necessary that is. So anyway, once you've set all this stuff up, which is really just handling our attached stream, then we can actually start the container. Looks like we don't have any actual interesting start options, which aren't that interesting anyway. It looks like you can specify a checkpoint. The container's already kind of set up, ready to go, and so start will just execute whatever its entry point is, or the default command. So we tell it start, is there an error? Okay, and then lastly, once it's running, and I'm trying to decide whether this is necessary, whether you might also want this to happen before container start. This is kind of a separate thing here. But the other thing you have to worry about when you're working with terminals is resizing. So if you were to like run something like top, it's got all the columns and it's basically sized to the exact size of your terminal, whatever that size is. And so the terminal system lets certain messages be passed to notify that the terminal has been resized so that the output can be redrawn for that new size. So whenever you change your terminal size, we actually have to tell Docker that, because it has to tell the internal process that it's running that it's been resized. So we actually call session PTY again, even though we did that way up here just to find out if there is one. We call it here just to get this a channel of window objects, which is basically just a height and width struct. And then we range over that, so as new window sizes come, as things are resized, the session gets it over SSH. And for every one of those, we call Docker container resize. Liza Horace, thanks for following. Feel free to say hi. So we're resizing the container, which again just relays. It's like there's several layers of relaying messages here. That's the world of plumbing for you. And then if for some reason there's an error resizing, then print it and I guess break. I don't know if this is the hello. I don't know if this is the best way to do. This was all an example anyway, so this is not like the best production code. Once we start the container, then we do a wait. So there's actually like a handful of options that we do kind of wrapped up in Docker run. And you can actually kind of wait for various states, and the state that we're waiting for is Yogintama. I All right. Well, anyway, thank you for following. Feel free to say hi as well. We're gonna wait until it's not running, so I guess that's the state the Docker has decided is the process is finished, and we get a result, which is interesting, and an error. Looks like then we just say, hey, if we get an error, then set error and then return, which returns the error. And lastly, we wait for a result. See, these are result C because they're channels, so we get the result. What is this? I guess it's some kind of struct, but it happens to have a status code, which we set. And then lastly, if there was any output error, we'll set error to that. But if these finish, and they return nil, then it's just going to send nil over this, which then says error is nil, and we return. Again, these are name parameters, so that's this isn't very common in Go, but there's situations where it's helpful. And so that's a Docker run. So it's pretty involved. I don't know if the library actually contains a higher level Docker run yet. If it does, it might be worth using. I kind of doubt that it does, but we should take a look since it's been a little bit. But this API is going to be pretty crazy. Let's try Go doc. Client, and it might be a high level thing. No, let's see if client actually has something where we can just do container run. Seeing anything. Yeah. So at least in this package, and I kind of doubt they have it in other packages. I know that there's some other Docker client libraries that came out before this official client library came out, I think. Which might have higher level stuff, but I don't really want to bother with a third-party client library. I think so I usually kind of just do all this stuff myself every time. It'd be nice though to have something that just, worked with this abstraction that we come up with and does all this. So that's another benefit of coming up with a good runnable abstraction. So let's see if we can, is there an example of kind of a more typical, so an SSH server that does not run Docker, one that just uses exec command. So to compare, let's look at this program. We can try running this one. There's also in examples in this Cloud Labs SSH library. Oh, not enough time for my donut. So now we have another SSH server, which we have to clear this. So by default, and I don't know what exactly to do about this, but these examples at least, they don't let you, so SSH, when you run an SSH server, you need to have a host key, because built into every SSH connection, it does host key verification. And this is where the whole like type yes when you first connect to something, or you know, like you saw before, where it's like, hey, is this a different thing? So basically what happens is every connection basically serves up the host key that you have configured, or a fingerprint of it, and then it's like, hey, here's the fingerprint. You've never connected to this server before, so do you want to remember it? That's when you say, or you know, is this fine? You type yes. It's basically going to store that in a file, so that the next time you try and connect to that server and it shows the host key with the fingerprint, it's going to look in that file and be like, oh, okay, I've seen this before. This is the same server that you've connected to at this address. And so then it's like, okay, you know, we'll connect. And you can turn off that with an extra option. The problem is, now every time you create any kind of SSH server, it has to have some kind of key. I'm not even sure, you know, what would probably be a good idea for this library is to just have a dev key that all of these use. But by default, when you use this and you don't specify a host key, it generates one. And the problem with that is that every time you run the server, like the same server code, you stop it and hit start again, it's going to generate a new host key. And then you run into a problem when you connect to it, because it's going to say, hey, this is the same address, but it's a different host key. So what I do in other projects, and I haven't done for this one, is to have a key included that's persistent, and it's the dev key, and then all the examples can use that. But since we don't do that, we have to basically, every time we start the server, we also have to run SSH keygen, remove the host key if it's in there, and then we can connect to it. So okay, we're going too far. This example is basically going to run top. So it's basically an SSH server that's hard-coded to always run top. Top being an example of something where you can resize the terminal. Yes. Alright, so here's top. Our SSH server up top. If we resize it, it reformats. Okay. I guess one way to think of console resizing is oh god, I forgot the word in web. Responsive design. I always hated that phrase because, like, it's not saying what it's responsive to. Like, there's so many different things that a design could be responding to, but it's specifically the size of the page. Anyway, so we can close this. This is a lot simpler than the Docker one, because it doesn't require us to create the container, attach the container, you know, all that stuff. We just have to do, you know, when a connection comes in, we set up a exec command. We get all of this stuff at once for whether it's a terminal. We actually don't. We just exit if you're not doing this in a terminal. So SSH, the client, is actually kind of interesting in that when you don't specify a command, it will say run this in a terminal, because it's assuming that you're going to want to run something interactive. If you're ever to specify a command, it's actually going to say don't run this in a terminal, and it runs, instead of creating a session in the protocol, it runs an exec, which is handled slightly differently in most implementations, and so it will not be in a terminal. So if we were to do something like this, no PTY requested, which you can also, I believe, pass some kind of option to, you know, force no PTY or force PTY. But anyway, the default behavior of SSH is good to understand here. So it's not going to work if it's not interactive. Another way to think of a terminal is interactive, because terminal is kind of ambiguous. PTY and TTY are, even though they're the same thing, because ultimately everything is now a pseudo terminal. You know, so maybe a shorthand or a better kind of mnemonic to think is interactive. Even though human interactive, like you're actually interacting with it in real time, as opposed to like interactive responding to standard input. It could be in a pipe or whatever, but so interactive is another way to think of it. So one thing that we do pass through here that we get from the environment of our session, PTY request. Oh, cool, interesting. So the protocol for SSH, actually, when you request PTY, I believe instead of it setting the term, so a common shell environment variable is term. If that's set, then whenever you need to run something interactive, this is the terminal mode. No, there are other modes that are kind of like flags, but this is the, I forget the exact word, but let's see, this do I have term set? So it's kind of like what what flavor of terminal. A common one is xterm, another common one is xterm 256 color. So this is just helpful for the other end to know what to run in, because basically all it's doing is forwarding these commands. Cedrix, Mexico City. Wait, I know your username. Who are you? We met, right? Or was it just in Slack? From DevHouse, yes, of course. Welcome. Thanks for joining and hanging out and saying hi. Yeah, Hackspedition. Oh man, I missed that. We can do another one. We can do another Hackspedition in Mexico. We're actually going to Cancun. Bunch of us just kind of taking a chill vacation there. It won't be as cool as the Hackspedition, but good to visit Mexico. So we were talking about terminals, so we have to pass this in. We actually get the terminal not from the environment. In theory, you could get it from the environment if you were to pass it, but anyway, when SSH, I'm pretty sure what happens is the SSH client, when it runs something interactively and it's going to pass, say, hey, run this with a terminal, it actually looks at your term, so it doesn't actually have to your value for the term environment variable, and then passes that in the message, which is why it's part of this struct for the PTY request. So anyway, we're just setting that environment in the command that we're going to run. When you run stuff with command exec, it sort of does not run them as in an interactive mode. So there's a library, there's a couple of libraries you can use to run an exec command interactively. This is the one that I'm using. All you have to do is say PTY start, and you get back a single kind of file object that you can read and write from. And again, when you work with terminals, even though they're kind of more complex, they are simpler in that you don't have to deal with standard out and standard error as separate things, because they're sort of consolidated into one at that point. And then we do listen for the terminal size changes. Because we're not calling Docker here, this is ultimately what Docker is doing behind the scenes on the other end when we call that Docker resize. It's doing a syscall that it's basically, this whole like syscall data structure. There's probably a library by now that gives you a lot of the standard syscalls in a higher level thing where you actually get proper structs and stuff like that. But a lot of the time it's like a one-off thing. So basically a syscall is going to be like more or less, well, so specifically these are IO control syscalls. And so it's like, here's the file descriptor I'm going to do the operation on, what is the operation, and here's the data for it. So we're just kind of wrapping that up in a set win size. And then we do this, which is kind of a good enough solution. Or maybe it's a good enough solution. Or maybe it's... Usually if you're dealing with standard out and standard error, you'd have to do something more complicated. In this case, we can asynchronously copy standard in, looks like standard in from the session into our interactive terminal, in this case running top. And we run that in the background, and then in this go routine we just sit here and wait for the output. As long as there's output, we'll send that into the session until that pipe is closed, and then we move on, which will basically just close the session. You know, another way people might do this is to run both of these in a go routine and then create a wait group for both of them. Which is actually probably the right thing to do. It's just that in the common case, like standard in is going to be written before standard out has finished, because yeah. Anyway, this is kind of a sloppy way to do it, but it works most of the time. And there it is. So in theory, we could get, for example, if we were to use an abstraction to kind of wrap up Docker run in something that looks a lot like exec command, we could get it to kind of be this small, a little bit more complicated because we still have to configure the container, but it would be a little bit better. So we're trying. So another thing this doesn't touch is what the return code is, or the exit status, because by default we're just going to return 0. But we do care what that is, and with exec you kind of have to do this extra step of, because it's OS specific, you have to get the error from wait and then cast it into something that will give you the status code, the exit code, which is the other kind of proper way to do this. This is a very straight, this example is just to show, like, this is what it's like to do an interactive command for this server, so it's not a complete example. So how do we simplify these, and how do we kind of combine these? My idea is, you know, you could think maybe it looks something like command, right? The command type is not you know, a proper interface, but its interface is, you'd think maybe something like, you know, that was the idea behind implementing this in implementing a Docker API with this interface. It's like, it's roughly similar. We have to deal with standard error, though I always was frustrated with these because I almost never use these pipes. For example, one way, let's see, how is this done here? Well, it's kind of because we were doing it this way, so we don't have to deal with it, but let's see. Is there an example here where, I guess there's not a ton of examples in here, because there's a lot of different ways you can use SSH. But a lot of the time when I run a command, I never use these standard error pipes, because I usually don't need, for example, standard out, I don't really need a reader. A lot of the time I have a writer that I just want standard out to go to, and what you can do in that case is actually, when you set up the command, you can actually just set the standard out to a writer. So for example, you could set it to OS standard out, and standard out of this command will write directly to your standard, you know, the program's standard out. which is a little bit easier than having to get a standard out pipe, which then you have to error check, and then you have a read closer, and which means you have to either do like an IO copy or some other kind of reader to read it in, and then just write it to standard out. So I almost never use these unless I'm in a situation where I actually need a reader, because you can imagine both cases where like, oh, maybe I need a reader because you want to do some kind of like output processing, and so you send it into like a buffer or something. But you could just as easily just take a buffer and which you can write into and put that into the command. So even then, I almost never use these. So I'm a little I'm hesitant to actually include these in any kind of abstraction. But this idea of having a wait, so you kind of call start and wait, or you could call run, which is basically doing the same thing behind the scenes. It's probably a thing. I think though, stuff in the standard, I think in this case I want to be more explicit about the exit code, just like the SSH protocol and API, because it's kind of it's an important thing, and it's a little annoying that Go standard libraries were designed to be as cross-platform as possible. So whenever there's anything that's Linux specific, a lot of the time it's hidden in here. So for example, when you do a wait or you do a run and you get the error, if it exited non-zero, if you want to get the actual exit code, you have to cast it to an exit error. Does it even error fails, doesn't run completely, exit error, and so exit error contains or has embeds process state. Oh, this is interesting. I didn't realize it has this. Holds a subset of standard error output from the command output method. That's interesting. Another way to get sort of sometimes standard error. Anyway, so most of the time you want this, which is going to give us stuff like, did it exit? Of course it exited. What the process ID was, stuff like this. Most of this we don't care about. The thing that we do care about is that's interesting. Status, exit status. Oh, do we really have to do another? It's been a while since I've written something that actually needs this. I'm trying to think of an example. Obviously, a good example would be command. Let's see if I can actually find the thing that actually runs a command. This isn't even something that would run a command because it's just working with Docker. Let's see here. I've done this so many times. Get let's see, get receive. I also rename stuff a lot. So I made a better version of this. Oh, but I did that for Flynn. So it's probably in Flynn archive because by now they don't really use most of the stuff that I wrote originally. Get receive D. There's so many things I've written that did this, but it's hard to think of specific ones. It's also been a while. Exit status. I remember I'd often create this silly helper. So you have to do all of this. So whatever the error we get from command exec, first we cast it to an exit error. And then once we cast it to an exit error, then we can call sys to get the status, which is a uint32 specifically. So sometimes we have to cast it to an int or whatever, interface. So it is kind of an obnoxious thing that the exec command package makes it so difficult to get the status code, because it's such a core thing to almost any kind of runnable thing on a. Like I wish that instead of, even though it's more accurate, it would have been nice if they would just have a status, exit status that would just always return 0 if it were Windows or something like that, or something. But this is kind of obnoxious. Whereas using SSH, the exit status is literally part of the protocol. So any session that you do in here has some way to send the exit code, right? So being explicit about the exit code would be really nice in this abstraction. So in a way, what we're trying to do is create something that has a little bit like command exec, the exec command interface, but also kind of looks like this SSH interface a little bit. But things that we don't care about that's specific to SSH is things like the user, remote adder, public key, permissions, signals, maybe, because that is a part of most runnables. And again, the idea is that once we have this abstraction, then we could use it to represent running some kind of Docker payload or an exec command payload or a payload via SSH, and then run, create a server that can kind of handle any of those. So now that we've kind of defined the problem, and this is a lot for me as well, it might seem like I was kind of spending a lot of time just going over stuff, but it's for me to kind of remember all this as well. So let's kind of start thinking about what this looks like. And the other thing is that this interface is for passing this data back. So, but okay, let's try and get back to exec here. And some of this is, it's defined via variables which you can set. So defining an interface, let's see here. Arguments can maybe leave path and args out. Maybe. Environment's probably important. Maybe we can't leave these out, because that's going to be common. Well, we might normalize them into generic command in the way that SSH does. So let me just think about some of this stuff. This isn't what it looks like. This is more of like notes right now, but I don't know, something like command. Right now we're not thinking about setting them, just kind of thinking about like the data structure that's kind of behind this interface. And for environment, I guess Go is often just We do have to figure out standard in, standard out, standard error. I don't know what those look like yet. Most of this, it's not necessarily a process, but there is process state, which most of the time we don't care about, but we do care about the exit status, or man, what there's so many different ways to describe it. Exit code, exit status. It's exit status, right? Okay. I think that's what it is in SSH as well, somewhere. So let's look at the underlying. Oh man, did they do it here too? If the command completes unsuccessfully, is rendered by signal. Okay, so at least we have this data structure here. Yeah, they call it exit status. Which returns an int. It's very frustrating. Sometimes it's an int, sometimes it's uint, sometimes it's uint32. Then we have PTY stuff to worry about, terminal interactive stuff. Let's get back to Exec or maybe SSH. Let's see what else we have in this session. Environment, command, PTY signals. Yeah, maybe signals. This is actually still disaster piece, but for a different. Let's try, even though it's kind of short. So again, kind of coming back to our goals, the idea is something like the equivalent of an IO copy. We want to be able to write something like an IO copy for runnables, basically, right? Like an IO copy lets us go from some, a reader to a writer, and in this case we're trying to run something and then sort of forward all of that information to something else, which might just be a convenient representation for us to work with, or something that an SSH server can just take, and then it knows how to pass all that stuff along to the session. So there's this kind of idea of the state of it too. Is it running start, basically start, wait, and run stuff. So one way to approach this is to kind of write what it might look like to use this. So you can kind of make a fake session handler here. And let's say we did a Docker run with some, you know, config from somewhere. And instead of us passing it a session, which then couples it to SSH, instead it gives us back like a, you know, this runnable thing, in which we could kind of then maybe describe it as the equivalent. Instead of IO, it'd be something like an attach, kind of borrowing terminology from Docker. Given this session, we want to attach that runnable to it. So then the question is, what does attach look like? Because that's kind of where the interface is actually used. This might do everything all the way up to including setting the exit code. But perhaps there's still an error to worry about. You know, this is example code, but so given something like a session, and I don't know if it's necessary to kind of abstract this idea of an SSH session. There's not too many cases where you'd have what is kind of like a runnable host or something, like a runnable relay, but let's see. So this now comes back to the start and wait stuff. So go IO copy will block until it's done. We'll kind of use that as a thing. So we'll kind of assume this is doing like a run. So that kind of implies, let's see. There being a run, which makes sense. It's a runnable. Where does it get that from? So let's see. So you can imagine this implementation being something like, oh, it's gonna run the thing. So we'd actually want to set up everything before that, because at this point, so it's kind of interesting to the idea of, you know, when you run something, you know, it could return non-zero, but it still ran. So was that an error? So I'm just thinking, like, conventionally, yes, it's represented as an error. If you were to do an HTTP request and you were to get back a 400 or a redirect or something like that, you know, what is an error? In theory, anything other than 200s are an error. I've seen different libraries handle this differently too, but the idea of this kind of like the semantics of what is an error in terms of the library executing the thing and the job being executed but let's just assume it does return an error. Though either way, we want the status code. So either way, at some point, we want to say something like runnable exit status. Maybe exit status doesn't actually return until the thing is complete. But this is almost like something you would always want to do. Right? In which case we're just going to return the error. But so in this case, if there was an error, it would return the error and call the exit code. Then there's all this setup, so we need to figure out how we would do that. In theory, this could also abstract the whether it's interactive or not. Though that's getting so some of this is set up, and it's trying to determine what is set up outside of this abstraction versus what is handled in attach. Guessing, so you definitely want to copy standard in. Standard in is also weird, which is why the Docker stuff has this like use standard in flag, because sometimes you don't want it to wait for standard in because there is no standard in. It's one of the weird things about kind of shell programming is it's hard to tell when you're supposed to expect standard in, because you could just read on standard in, just not get anything because there's nothing there. So knowing whether you do that is kind of an interesting. It's either based on conventions or assumptions or whatever. I'm kind of surprised when I found out that there's no good way to check if there is standard in, I was surprised that things work as well as they do. I mean, you can actually check to see if the file descriptor for it is closed and stuff like that, but depending on the abstractions you're working with, you don't necessarily have that. So. Pretty sure this is gonna look a lot like this. I'm just gonna do this to get something on there and then iterate. IO copy. No, we're actually running this into Runnable standard in session. I guess the other part, and again, it's all like just like little details. Closing pipes, because maybe that's a reason why people would want to do get pipes for their streams, because they're right closers, right? Pipe will be closed automatically after wait sees the command exit. A caller need only call close to force the pipe to close sooner. So it sort of has a optional closer. For example, if the command being run will not exit until standard input is closed. Copy doesn't care about closing, does it? So. And then how we handle standard out and standard error, again, it depends on the terminal stuff, so. Man. Yeah, I'm just gonna write some like high-level pseudocode and then see where we go from there. Do we know if Runnable is PTY? It's really defined by how it's run. So then it can be set up in a way to be PTY or not, but then we need to check to see that state. So something like Runnable is PTY, you know. Whereas if there's none, we have to do one of these for both standard out and standard error. It's interesting that if it's the exact same thing, then obviously we could just always do standard error, standard out. But are there other things we have to do? I mean, there are, for example, the resizes. Resizes are weird. How do we think about resizing with Runnable? If we don't think about resize, then we basically have to say, well, we're not going to try and abstract interactive stuff with this. Which is actually, I think, part of what makes this kind of a useful abstraction, just because it's obnoxious to have all these if state. Make sure you do everything different for an interactive thing versus not. So I'll start by doing something like this. This is a function, or it's gotta be a function, right? I'm pretty sure there's other stuff besides resizes that you'd probably want to think about, like signals, sort of. Because the other thing about interactive is it changes the way signals work, because thinking about interactive as like a wrapper for a process, normally when you run a process directly, you get standard out, standard error, and you can send signals to it. When you run it through a terminal, like I said, thinking of it already as an abstraction where it's already going to read standard out and standard error and then normalize them into this single, file descriptor interface that can then have certain options set for that, terminal specific options. But because you're working with a terminal, you don't send signals to a process. If I recall, a lot of the time signals are sent via standard input with certain escape characters. It also limits what you can send, so it's like interrupts and stuff like that. And then that will then translate to signals in the processor. I think that's how it works. I remember something like that. Let's see. But we definitely want to handle resizes, sort of a minimum common thing. Yeah, it's raining out. I wonder if I can rename this without saving it. So I can get that colors. This is a Docker. I'll call it Runnable Go. What did I do here wrong? This is not how you do interfaces in Go. Yeah. This isn't a real Go file. I just wanted it to be colored correctly. So let's look at so the resize. I mean, you can think of doing this a couple of ways. You could basically abstract this loop, so you give it a channel of windows. The other thing, though, is you get an initial window size. Right, and the environment. Don't want to forget that. I'm trying to decide whether or not Runnable should have something like resize. Or which is you call for every resize, in which case it takes like a width and height or something, or it takes like you know, some kind of channel. You know, of a width and height. And then and then it'll just do that loop and do what it needs to do. Kind of like the second one, though it being a window means now we have like another struct involved here. be an int slice, maybe? I don't know, that starts getting nebulous in terms of definition. Plus, so does a runnable handle its loop? It seems like better idea not to, though. You know, if it was just width and height, you have to do it yourself. We would already know this by now by the runnable being set, and I think we will need that though for the terminal. Start talking about environment stuff. This is kind of the IO section, and we can set up the environment after. I guess another one of these. This is specific to the SSH stuff, and then this part is runnable, these size, width and height. Besides setting up IO and environment, what else do we care about? I mean, Windows size is actually kind of a separate thing, but let's see, start. It's almost like interactive stuff should be on its own thing, you know. Alright, so we got window resizing. Thinking about I wish I was thinking out loud. Environment. What is that actually? I'm thinking of. No, just link me to it. There's a couple, of course. Probably find them in related articles. It is the transport authentication. Maybe it's in protocol architecture. No. Yes. Just I have a name for it. It's like these are the terminal modes. Term represents terminal capabilities. I mean, I wish there was a name for this string. Terminal type, I guess. I guess so. Terminal type. Get that from here. Oh man, we gotta figure out how we're gonna interact with the environment of this Runnable. What is has set end, right? Okay, key value. So maybe we have set end. Remember, this is all pseudocode. I'm trying to figure out this abstraction. So this is more like Runnable set end. term. Oh, and then there's modes, terminal modes. What else do we care about? Yeah, what do we do about, does resize return an error? I mean, when you do a syscall, we'll get an error, so. What is the right thing here? Probably just to have attached return, right? Any of these things is error. And it's probably a good idea to handle all errors if this is a sort of generic thing, so. I mean, there's, right, container weight. They set it up so it could return a channel of errors. I don't know how I feel about that. I'm thinking even if you were to return the first error, how do you do that in a way? Because now, if, like you do a channel, like once you get that error, and maybe you close the channel, there's potentially other errors that could be sent to it, which is bad. I guess we could have an error channel for every one of these and then do a giant select at the end. I guess, right? What happens when you write to a channel that that's sort of like otherwise not being used anymore? That's actually something I'm not sure of. Where are my Go experts? Anybody in the channel? Know more about that than I do? It's not hard to know more than me. Guess we can read the docs. Let's see. So the statement says channel expression must be channel type, channel's direction type, and the value must be assignable. Both the channel and the value expression array are evaluated before communication begins. Communication blocks until the send can proceed. Send on an unbuffered channel can proceed if a receiver is ready. A send on a buffered channel can proceed if there is room in the buffer. A send on a closed channel proceeds by causing a runtime panic. So right. How would you need to like maybe do something with like a barrier or something where if any of them are caught, then none of them are going to try and send. What would Rob Pike do? Maybe somebody's explored this already. I'm not sure what I would do to look this up, but multiple errors. A list of errors. Yeah, I don't know, man. I mean, if my application called for this, I would do this, but what is the like Go idiomatic way that you would put into a library? When was this? 2014. Most functions will abort after the first error, so a single error is much more common than multiple errors. You have multiple errors, you can do something like this, and error slice fulfills the error interface itself. App Engine implements multi-error type. It's used when fetching the entities, and there's a number of them. Could be an error. It's a bit cumbersome to use. Right. I would imagine you would create something that would just return the first error. Consider returning error. Multiple errors. I decided not to go through because if my function could go on after hitting error, then either. For examples of functions that accumulate errors instead of aborting. See, ooh, yes, that's very good. I will check those out. is the client's behavior going to be any different if it receives a single error or multiple? Sometimes I do this. Oh, it's Peter. Yeah, building up errors. Well, let's see what these ones are doing. Now to find out where these are. It looks like in an error list. Is that okay? It's a list of errors. Okay, so they do the same thing. They set up a, they make an error list. It's part of their package. Well, what would that look like? So I could maybe in this case I can have a single. Problem is, if we return on the first one, those errors would append to the list afterwards, because these are things that could happen later. We may just need to think about this problem a little bit more specifically and concretely, which now requires some specific ideas around standard in and stuff, but like lights flickering, you get electrocuted. If a resize fails, it should abort the attach, which would mean closing. I don't know that we want to close these though. So maybe we don't care about resizes failing. It's really just a message, like either it gets it and resizes or it doesn't. it would be pretty obvious. When it's not working. Let's see, what does this do? How do they combine this? Give me the definition. So this is a loop. It looks like it just returns the first error it runs into. I'm kind of curious whether this completes or if it just hangs there, but it's kind of what good defensive coding would mean I would know by now. So I'm clearly not a very good defensive programmer. I guess I can kind of come back to this error stuff and get back to this abstraction here. But let's see. Right, we have the environment, which we would need to do some splitting, so for session has what? Session has environment, but it doesn't want to show me that. In theory, this could also be an error, so... Maybe I don't want to defer that. Hey! What? No! I don't know what this is. So now it's a little confusing whether or not it returns and it gave me an error, but did it send the exit? I guess the same problem with all of these if we get the error for all of these. Maybe this is actually something that attach doesn't do. It doesn't do the exit. You can do the exit afterwards. It's so easy to get. If I want to do error handling there, I could. Try to minimize the amount of things that attach does and get to worry about errors and stuff for while still making it a pretty good experience at a high level. For those pipes to finish. Let's see, I was just working on something that needed go. So pipe weight was just for, okay, so that never dealing with standard end. You know, I've never looked up though why, oh no, it's for the closing stuff. Pretty sure. It'd be interesting to see that implementation, but I really get to a point where I feel, you know, some kind of point of conclusion here, because I think we're really close. Seems like we don't really care about the directory. almost don't even care about the command. And the only setter we have is for the environment, because that is something necessary for attaching environment, passing it along, as well as the interactive part. But then it's interesting that nothing else has a setter. Time for a nap. Or coffee. Anybody have thoughts? Questions? What's going on? I know I've been staring at this for a while. It's kind of getting to that point where I'm, you know, getting caught up in the weeds on some of the stuff. Not having a clear idea of what to do next, but I think at a high level there's something good here. And it would be interesting to make this real and then get Docker to run in our example to actually return a runnable. But then also to have you know, a wrapper for exec command. What's an example application or other use case for this library? So library wise, I guess the idea here is that it's not as much about a library as this is an exercise in kind of designing an API. Because I write a lot of stuff in that, like an SSH server or something, that either does a client connection to another SSH server and it's like a gateway, or it runs something in Docker, or it runs something using exec command, right? And so all three of those cases are totally different. Like, they have totally different ways to, you know, this is what it's like to run an interactive command locally with exec command, whereas running Docker requires kind of all of this stuff. And so I'm trying to find some commonality in them to make just to kind of help clean the code up in those kinds of systems. So, I mean, the examples are, if you wanted to make a Docker SSH gateway, which is, things like command IO do that. This example does that. Obviously, you could just do it directly for Docker like this. But hopefully it could be a little bit simpler and maybe more readable if it was very similar to the example for this. And so I guess the idea would be to kind of both simplify and make more common across these different use cases, and then having this attach function kind of built in that leverages that interface. Because now in any of those cases, if you build something that returns a runnable, you can just say attach. And in this case, attach is only useful in cases where you're building an SSH server. But if you were, I could think of some contrived examples where you weren't running an SSH server, but that would require some kind of abstraction of session. So in a way, attach is a convenience for the Golang Labs SSH library, and having this interface available in that library then makes it a lot easier for people to think about how they would build interfaces for things, because it becomes a very standard way to build a server, to build an SSH server that connects to SSH or connects to Docker or shells out, which are like the common things that you do when you make an SSH server. So it actually makes sense that this is part, I'm working on this inside the Golang Labs SSH library, because this interface is what will enable this function. This function makes it easier to write certain kinds of SSH servers. Cleans them up, tries them up. It's certainly not necessary. It's arguably a little masturbatory in the sense that you could just write code to do the thing that you want to do, but this Docker example just feels so chaotic, and so by doing this exercise, hopefully that will help start cleaning that up and make it feel a little bit nicer, just because we do this so often. And to have that separate, then the attached part separate from this, then we could also then create a really simple Docker run abstraction that works in most cases, as opposed to doing this giant one-off thing every time we do something that connects to Docker. So it's very abstract. In fact, it might be fun just to start implementing our own Docker run that returns a runnable as well, just to kind of move things along to a point where, see, in this case, I wouldn't need to do a session and let's see, container we wouldn't have to do any of this. We just have to return a runnable. Let's see. Which means we'd have to create a Docker runnable. That implements all of these. So I'll ignore signal for now. I guess also actually make these actual interface definitions. So string. Standard in, we're kind of expecting it to be a writer. These are readers. Say that's an int. Say it returns an error. This is a bool. Int. This implementation is specific to Docker, so Docker runnable. Let's see, so we'd have a client here, probably, right? It's not giving me a client. I'm guessing that it's gonna be like client. I don't know why it's not. Oh, because I'm not including anything because it is not. Let's make this a valid thing here. So that we can actually get autocomplete. Oddly, it's not telling me what's the problem here. Oh, I can't call it var. That's true. Okay, so now what is the problem? Oh, yep. Okay, and then all these, this is, right. You could say Docker runnable. This is like new Docker runnable. If we put this into its own package called, Docker and a runnable subpackage, this would be new runnable, Docker do runnable, but probably wants to take a client too, but too many errors. I like how the last one is just too many errors. This one is undefined, that's true. I'm just gonna then replace it with kind of an empty config. Docker runnable. What do I call it? Undefined S. That's true. What is the problem here? Missing a return, huh? What else? Alright, missing function bodies. We got undefined status, that's true. Don't care about that now. This whole thing is going to be kind of cleaned. I mean, probably actually just need to comment all this out. And just reference the other thing. Stubbing these out. So that okay, auto does that. And then we were talking about this. API client. Let's do client. Probably just want to take a client in here too. What else? Because of this, kind of have to worry about keeping this environment. Let's see, runnable. Exit status. Once we have that, we just want to set it so that this is kind of I'm trying to figure out what this should do if you were to call it before it has exited. It could wait. It could return an error. It could panic, which probably the thing to do. It's funny because panic is sort of a used to me. I think of it as kind of like an assertion. It's like the only time you use it is when something is done that shouldn't happen if you do things right. You know, like writing to a channel that's closed. If you're trying to get the exit status of a program that has not exited yet, it returns a panic. So I'll do that for now just because it's the simplest API. So that doesn't change that, but it does mean we would want to keep the exit status around. Is PTY. Let's see here. Docker runnable. I'm gonna make this Docker runnable. Even though this, you'd imagine this could return the interface runnable, it's idiomatic to take interfaces but always return pointers to this specific thing. Docker runnable. Actually makes sense to put this up here so we can see it. It's also typically how it's organized. So now we can go back to this and kind of see what we're doing here. We do this outside now. Maybe we want to take a context. Let's see, background. Host config, I imagine. What are some things we do? We've got the client, which is coming from there. We've got the config. Oh. I guess we don't need to keep that around. But we do want the container ID. Some stuff that's specific to Docker. So result. We can't do that yet. Client. Yeah, that's silly. And then this. Client, take out context. I'm going to do it without a context for now. These all need to be updated. Client. That's true. Now we need to do this. So, I mean, I want to use it. Let's see. We're going to return it. Okay. Well, what is it? What do we have? We have ID, which is a string. That's right. Container ID. If that's an error, then return nil and error. Otherwise, run container ID equals res ID. Okay, so this is good so far. then what did we do? Container create. Figuring out how to do this cleanup will be interesting. Then we do this attach. Let's see. The attach would happen in our run, so we would come back to that. Is pty. Actually, it's part of this config, so we don't actually need to keep that state, although we don't keep the config around. I guess we can keep the config around and do it that way. Okay, so this is as simple as returning. I imagine we're just gonna have to mutex this up. Doctor unlock, and we return. And we'll do the same thing, but we will append doctor and strings join. Probably call these by their full name. What did I just say? Run is the big one. This one is just gonna do status. Still not sure how these are set up, but we'll get to that. Yes, we want to. Okay, this is where it gets interesting. Interesting, because I was thinking those would be set to run. That happens down here though, so what the hell is this? Probably have to do some pipes or something, although because I'm it's probably a good place to stop so that when I come back we can start dealing with some of this IO stuff and then do the run. And then we can kind of clean it up and actually use it and do this example. And it would be a lot cleaner than this. And then we could use the same interface to make this clean and clean up a bunch of stuff. But I guess I'll do that on another stream. We'll see. It depends on I don't know, I might do it. I could do it on my own and stream other stuff, or I could keep streaming this. We'll see. If let me know if you want to see the conclusion. If you're watching this on YouTube, leave a comment. Because yeah, I think we're pretty close, so we'll see. That's it for today. Let's see, I guess I should put this up. It's on a different branch. So, this is a total work in progress. So, where did I modify in Docker? I added some lines. Alright, well, I'm gonna the Runnable API. So this is actually up. If you want to refer to this code, think about it, ask me questions or whatever. It's here. Yeah, still a sketch, but otherwise, we'll see if I do this again. Let me know. And thanks for everybody for hanging out. And this will be on YouTube. Went a bit longer than I thought I was gonna go, but designing, exploring stuff is a long process. We'll see how interesting it is to continue streaming stuff like this, but it's probably more fun if I had more input. But we'll see. I probably just need to get more people hanging out here, which might mean I have to start doing some other stuff that's less interesting to me, but we'll see. Alright, everybody. That's wrong. Have a good Sunday. See you later.